Alright, so this is triangle proofs and the CPCTC. Before we started, I asked you to look up CPCTC. So I'm assuming you got that on your paper already, so I'm not about to write it. But I will ask Billy. Billy, what did that stand for? You missed a word. Just say, Vion, go ahead. There it is. Yeah. A CPCTC statement, you can only make it after you call two triangles congruent by some kind of congruency rule. So all this is an additional piece of information we add in onto our proof. The proofs aren't changing at all. But you need to understand the proofs that y'all did Monday and Tuesday, all those proofs, you were just trying to prove that the triangles were congruent by some kind of congruency rule, whether that be side, 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 angle, side, angle, angle, side, angle, side, angle, or HL. CPCTC is after you prove the triangles to be congruent, then you could talk about parts that you didn't mark on the triangle. You could say, so since you proved the triangles are congruent, you know that all the corresponding parts on the triangles are congruent. So CPCTC is an additional statement you make after that to prove that parts of triangles are congruent, after you prove the triangles to be congruent. It'll make sense once you see one. So we use CPCTC used when asked to prove parts are congruent. But first, before you can prove parts are congruent, you must prove the triangles are congruent. That's what we did Monday and Tuesday, prove triangles to be congruent. After that, we're just going to do an additional piece of information to prove that certain parts are congruent. And if you look, these proofs look a little bit different at the end. Start out the same. They give you information. On this first one, it's a sample CPCTC one. Give me information about the proof. They tell me these AB is congruent to AD, BC is congruent to DC. Then it's what they want me to prove that's different. Before, if you look at your stuff from the other 2 days, this right here always said a triangle was congruent to a triangle. This time they want me to prove that angle BCA is congruent to angle DCA. I'm not trying to prove the triangles congruent. I'm trying to prove these parts are congruent, these two angles. But before I can prove these two angles to be congruent, I have to prove the triangles to be congruent. So I'm basically doing the same thing we did the other day. It's just that last line of the proof is not going to be a triangle congruent to a triangle. It's going to be what I'm trying to prove, in this case the angle congruent to an angle. But I have to prove the triangles first. And I say that showing you this. If you look, the line before is the line we usually stop at. The triangle congruent to a triangle, but we're going to take an additional step after that. After we prove the triangles are congruent, and then we're going to tell that since the triangles are congruent, we know these angles to be congruent by CPCTC. That's really it. There's not much different than what y'all did the other day. Starting out, Jasavion, the first proof. Let's roll. This first statement says AB is congruent to AD. What's the reason for that? Given. They call stuff congruent too, so we should mark that on our figure. It said AB is congruent to AD. The next line, just say they said given. Good. BC is congruent to DC. We should mark that too. And then just say they say reflexive property. Look at the statement and see how to name it. Oh, no, you can't look at the statement. Well, you can look at the angles, I guess. No, man. This is a reflexive property. Torres. Yeah, you can do that. AC is congruent to AC. mark that. I don't know how you don't know that at this point, with all the proofs that we've done, bro. And then after that, Taurus, you might as well finish. Triangle ABC is congruent to triangle ADC. This is side congruency. If it should be obvious to you if you mark your figure up correctly. Then after that, this is when we're trying to prove what we're trying to prove on this proof. Now that we know these triangles are congruent by some kind of congruency, which is side, we can mention anything about any parts on this triangle that they want. They specifically want us to talk about, and I'm doing it in a different color. You don't have to mark this. I'm just showing you now. They say B angle BCA, which is this angle, is congruent to angle DCA, which is this one. Yeah, I can definitely say that these angles are congruent now because I know these triangles are congruent. So that means all corresponding parts will be congruent. So this is where I want to make my new statement here, the CPCTC statement. I want to say, yes, these angles have to be congruent because of CPCTC. Corresponding parts on congruent triangles are congruent. I proved the triangles to be congruent, so my corresponding parts have to be congruent. That's pretty much the additional thing I'm teaching you today, CPCTC. You just got to recognize when you got to use that. Pay attention when they say prove, and that's for those who've been doing this well. Just make sure you pay attention when they say prove, about the prove part. You can tell. All the ones the other day, and I'm going to go back to my sheet. This is practice day 2 that y'all did yesterday. All these proofs that y'all did yesterday said a triangle was congruent to a triangle. Triangle congruent to a triangle. I mean, every last one of them was triangle congruent to a triangle. That's what you were trying to prove yesterday. Triangle congruent to a triangle. Today you're trying to prove corresponding parts congruent. So this is when you have to make that extra step. Make sure you, on the test, you pay attention to that. If they asking you for corresponding parts, then that's mean you got to take the extra step and mention CPCTC. This one, given PS is parallel to QR, angle QPS is congruent to angle SRQ, and they want us to prove PQ is congruent to RS. Rama, it's a good one for you. It starts off, it says, since it is blank that PS is parallel to QR. Say it again. Given. So I'm going to put F there. And then we can mark parallel on here. Make sure you do arrows, not side markings. So it said PS is parallel to QR. Then after that, they say angle QPS is congruent to angle SRQ. Oh, well. Oh, no, that's given too. I'm sorry. We need to mark that. Not yet. I know where you're going, but we're not ready for that yet. This is another piece of given information, Rama. So they say angle QPS. We need to mark that. Is congruent to angle SRQ. They just told us that. The two given things they put right there in the same little first sentence. It says since it is given that this is parallel to this and this angle is congruent to that, both of the givens are right there together. So that's it for the givens. And we just mark that on our figure. That's not hard to do. Then after that it says we can say angle PQS is congruent to angle RSQ because, hold on, Ron, before you say that, let's mark it so they can see it. I know you know, but let's mark it. Angle PQS, and some of y'all still don't know how to mark angles. That's why you're struggling. When I was coming up my desk yesterday, I was asking kids. I was like, just mark these angles for me. Don't do nothing else. And half y'all can't mark angles. And I don't know what to tell you about that. That's something I've taught you, and taught you again, and then taught you again. And I told you it's going to be important. Some of y'all didn't take me seriously, and now y'all struggling. They're going to name angles with 3 letters. They have to. To find where the angle actually is, look for the middle letter. The other 2 letters just guide you to what side of the lines you should be on. They call this angle PQS. I'm going to show you one more time right now. Angle PQS. PQS. Middle letter is where the angle is. That is angle PQS right there. RSQ. Middle letter is where the angle is. RSQ. It's just showing you where you should be, what side of the line you should be on. Some of y'all still don't know how to do that, and I don't know how else to teach you that. Alright. And once you mark those wrong, it's pretty obvious what they're showing you. It says we can say they're congruent because blank of parallel lines are congruent. What? Yeah, alternate interior angles of parallel lines are congruent. So A. Then after that, it says we also know blank by the reflexive property. And that's something we should have changed on here. I don't agree with that. We should have had another one on here. All y'all changed that option down here too. We should have had another option on here. This is the wrong one. This should say QS is congruent to SQ. This is a rotation. We should have changed that on this sheet. I don't want to teach you wrong either. That should be SQ. And I think on the test we'll give you the right way and the wrong way. You need to understand, see what the right way and the wrong way is. On this one it should be SQ because this is a rotation, not a flip. So we'll call that G. Oh, right here. Reflexive property. And make a note to myself to change that for future references. Due to the blank congruence postulate, we ain't marked that wrong. Why you didn't tell me? We need to mark QS congruent to QS, and then we can read our congruency. So at this point, Rama says due to the blank congruence postulate, which one? AAS. So C. Due to angle, side. If you mark your figure correctly, you should be able to see that. Do not read the parallel markings. Some of y'all be reading those and be messing it up. We can state that what? Thank you. We can state that triangle QRS is congruent to triangle SRQ. I feel like we messed that up. QRS. No. How do we mess this one up? We named the second one wrong. QRS should be SPQ. Dang. There's two mistakes on this one. Change that to SPQ. My bad. Down here. That's the second triangle should be named SPQ. We jacked this one all up. All the other sheets we went through and edited. I didn't write this one, guys. And then, so make sure you make those two adjustments on that, because I don't want to teach you this wrong. You have to name the triangles the correct way. They call this first one QRS. The second one has to be SPQ. And then the last thing, since we know blank, we can conclude that PQ is congruent to RS. Rama. Yeah. The CPCTC statement. Since you prove the triangle is congruent, you can make a statement about corresponding parts. Corresponding parts on that triangle would be PQ and RS. Like I said, it's only that additional piece of information. Other than that, the proofs are the same. Do the two on the back. You're knocking like we don't hear them.